Welcome to my infographic, that is topic 4, which is multiplicative and proportional thinking. I'll first start off by explaining what exactly multiplication is. Multiplication is basically a quick way to add the same number many times. This is useful as it helps us find the total when we are having equal groups of things. An example of this is shown down below. There are 3 bowls with 4 pieces of fruit in them, and if you want to know how many pieces of fruit you have in total, instead of adding 4 plus 4 plus 4 together, you can instead multiply 3, being the amount of bowls, by 4, being the amount of fruit in each bowl, to get a total of 12. So, before we move on further, let's go over a key concept that was learned in topic 1, which is place value. Place value tells us the value of each digit in a number based on where it is positioned. Each place to the left is 10 times bigger, and each place to the right is 10 times smaller. Without this understanding, the students will find it very difficult to do multiplication as well as be able to use it to help solve bigger multiplications. And in the infographic, I've got a little picture of the columns of like the tens, hundreds, ones, and tenths and all that. So moving on, place value partitioning to multiply. So it helps us like break it down into ones, tens, which an example of that is 37 times 13. You can break into 30 times 13 plus 7 times 13, which can then be added together to be 390 plus 91, which a total is 481. And then we can move on further from that to place value to partitioning to divide, which you break down the numbers into friendly parts using known multiplications to simplify. So 48 times 5, you can break down to further to be 45 divided by 5 plus 3 divided by 5. So 45 divided by 5 is equal to 9, and you can't divide 3 any smaller by 5, so it's 3/5. So the total is 9 wholes and 3/5. And then what proportional reasoning is. It is a way of thinking mathematically. Students who reason proportionally appreciate the multiple relationships between quantities or measures that are evident in situations of comparison. This quote is from the Blair House Post Leash 1992. That's a little quote I thought was cool to keep in there. Proportional reasoning means thinking and comparing amounts by using multiplication instead of adding or taking away. Thinking of all that will lead on to our next section, which is like fractions, ratios, and rates. Fractions will be something you've definitely are already familiar with, as is something that was like brought up about in the topic 3, which is the topic before this one. So we'll just go over that quickly. So fractions are a way of showing a part of a whole. For an example, if you cut a singular cookie into quarters and eat 1/4 of it, you'll have 3 quarters remaining. Fractions and percentages are quite familiar, as they both show how like one part compares to the whole. Now going back to the cookie, there are 75% remaining of said cookie if you're talking about percentages. Now let's build from this from ratios. So ratios are slightly different. Ratios are a way to compare 2 or more quantities. It tells you how much of one thing is compared to another rather than its parts to one thing. Ratios can also show the relationships between different parts of something or the whole. For example, if you had a classroom that had 4 blue balloons and 8 red balloons, the ratio of blue balloons to red balloons is 4:8 or 1:2, as there is 1 blue balloon for every 2 red balloons. The ratio of blue balloons to the total is 4:12, which is part to whole. So now let's build from that. So ratios and units. We can only use ratios when the comparison makes sense. Ratios show how much one relates to another, but they must be used correctly. Like when we're counting things, ratios can be compared groups or objects. So examples of ratios are the same unit example. Imagine you have a flower garden with 3 meters of roses and 9 meters of daisies. Both are measured in the same unit, which is meters. So it's fair to compare them using ratio. The ratio of roses to daisies is 3:9. We can simplify this by dividing both sides by 3, which is 1:3. This means that for every 1 meter of roses, there is 3 meters of daisies in the garden. So the garden has 3 times more daisies than roses. So building from that, when comparing 2 different kinds of measurement like distance and time, you keep the units in the ratio. So example, a car travels 120 kilometers in 3 hours. So the ratio is 120 kilometers to 3 hours, which simplifies to 40 kilometers per hour, which means the car travels 40 kilometers every hour. Now let's move on back and talk about ratio tables. It is a way to organize and compare equivalent ratios. It helps you see patterns, scale numbers up or down, and find missing values. Think of it like a multiplication ratio, and each row or column shows how two different quantities increase or decrease together. For example, every 2 cups of cordial is equal to 5 cups of water. So the ratio is 2 to 5. And I've got a little example of like if you have 2 cups of water, 5, 4 cups of cordial, 10 cups of water, 6 cups of cordial, 15 cups of water, and so forth. Now let's go over rates. Rates compare two quantities that are measured in different units and shows how one changes in relation to the other. It tells us how much something happens, is used, or is produced for each unit or something else. Rates help us describe how fast, how often, or how efficiently something occurs. For example, a person's heartbeat beats 72 times in 1 minute. So the calculation would be 72 divided by 1, which is equal to 72 beats per minute, meaning the heart beats 72 times per minute. Now let's go back to the top. So proportional thinking is pretty much when you start to notice the relationships between numbers, sizes, or amounts, and you begin to understand that when one thing changes, the others change also in the same way. So building from this, we've got an example. A basket of peaches that has 15 pieces of fruit and a basket of watermelon that has 3 pieces of fruit. An additive comparison of this shows you how much more or less one thing has the other. So additive using addition and subtraction to compare. So the peach basket has 12 pieces of fruit more than the watermelon basket, because 15 take 3 is equal to 12. Now I've got a multiplicative comparison. This shows how much times bigger or smaller one thing is compared to another. We use words such as times, as much as, big as, etc. Multiplicative is multiplication or division to compare. So the peaches basket is 5 times as many fruits as the watermelon basket, because 15 divided by 3 is equal to 5. Lastly, statistical thinking means using data to understand the world we make to smart decisions. It's about collecting information, looking for patterns, and using what we find to answer questions or make predictions. This builds from proportional thinking, which helps us find quantities to relate to each other. When students use proportional thinking, they better understand data by comparing parts to a whole, finding averages, and thinking about how likely something is going to happen with chance or probability.